Hello there, everyone. My name is Sathyam, and I'm a third year student at Indian Institute of Information Technology, Sri City. And I welcome you all to another previous year session of physics we are going to take over here. So, the chapter which we are going to discuss today is motion in a straight line. So, let me tell you something about this chapter. So, motion in a straight line is basically a part of kinematics. Okay, it's a part of kinematics. So kinematics is the first chapter which we deal in physics, and this is mainly divided into two types: kinematics 1D and kinematics 2D. So in kinematics 1D, we basically deal with motion in a straight line, which we are going to discuss it today. And in kinematics 2D, we basically deal with the projection motion or projectile motion, whatever you have studied, right? So we'll be dealing about motion in a straight line. Okay. Yeah. So a particle moving along x-axis has acceleration of f at time t, given by f is equals to f naught into 1 into t divided by capital T. So they have given the equation of acceleration in terms of f, where f naught and t are constants. Okay, f naught and t are constants. A particle at t equal to 0 has zero velocity. So if a particle at t equal to 0 has zero velocity, then the initial velocity, which say u, that is 0. Okay. In the time travel between t0 and the instant, when f is equals to 0, the particle's velocity is vx. Okay, so they are asking what is the speed of the particle during this instant t equal to 0. Okay, so note here one thing: we have f. All right, f is equals to f naught into 1 divided by small t divided by capital D. Now they have said us that f is nothing but acceleration. Now we know that what is acceleration? Acceleration is nothing but rate of change of velocity, right? So that will be dv by dt, right? We can say that f is equals to dv by dt. dv by dt is nothing but it's a differential form of representing the change of velocity with respect to time. All right. Now what they have said is that if f is equals to 0, they have mentioned in this question that at time t is equals to 0 and f is equals to 0. So what we basically have to do is, in this equation, we just have to put f is equals to 0. If we put f is equals to 0, we'll be getting time t is equals to t, small t is equals to capital T. All right. So then what we can do is we can integrate the velocities from 0 to v2. Why 0 to v2? Because they have told us that you have to find the velocity of the particle at that specific instant. Okay? So from small t equal to 0 to small t equal to capital T, the velocity vx will be equal to integral of is equals to 0 to e is equals to v2 dv. All right. This is nothing but small time t equals to 0 to small time t equal to capital T. And over dv, what you have to write? At dv, you just need to replace this equation which we have kept it over here first. All right, this equation. That is what they have given to us, and nothing. You just have to basically compute the integral of this specific equation. So they have mentioned us that f naught and capital T are constants. So you just have to integrate t. So integral of x is nothing, dx is nothing but x square by 2 plus c. Right? Everybody have studied this in mathematics in the integral equations, right? X dx is nothing but x square by 2 plus c, correct? So here, this equation will be getting integrated from the limit equals to 0 to t equals to capital T. Therefore, we are going to get the value as half of f naught into t. All right. Let me again explain you this question. What we have done is that they have given us the value of acceleration in terms of this equation. Okay. When as f is equals to f naught into 1 by small t divided by capital T. All right. This is the equation of acceleration. Now what they have told us that where f naught and t are constant. Okay. So f naught and t are constants. Now that person has told me that what is the acceleration? Okay. What is the particle's velocity vx? Okay. During the time when small t is equals to 0 and acceleration is equals to f. So you don't have to do anything. You just have to do dv by dt equals to f naught into 1 by t divided by t. Over here, you just have to replace it by 0 and then again integrate in terms of velocity, not in terms of time. All right. Just first bring it in terms of velocity. Once you have brought it in terms of velocity, you have to change it in terms of time. All right. Okay. So this one is clear. Let's move to the next question. A person traveling in a straight line moves with a constant velocity v1 for a certain distance x. All right. So they are saying that it's a straight line motion with a constant velocity v1 for a certain distance x, and with a constant velocity v2 for the next equal distance. Then what is the average velocity v? Okay. So what they have said is that a person has started from some particular point. Now, till a specific distance x, okay, till a specific distance as x, the velocity of this person is v1. All right. Now, when he moves more x distance over here, the velocity has changed. It changes to v2. But note that the person has traveled the same distance for both the velocity. Okay, for both the velocity, the same velocity. So, what is the average? Have asked us what is the average? Uh, yeah, the average velocity, right? So the average velocity will be v is equals to x plus x divided by, because t into x by v1, okay, and t2 is equals to x divided by v. This is basically the time t1 for the x distance when the person was traveling with v1 velocity, and this is the time t2 in the second situation when the same person travel the x distance but with velocity v2. Okay, because we know that speed is equals to distance by time, correct? You just interchange velocity and time over there. So you get t1 is equals to x by v1 and t2 is equals to x by v2. All right. Now what I'm going to do is the main velocity v is nothing but x plus x divided by t1 plus. You need to calculate average, right? So this is 2x divided by x by v1 plus x by v2. All right. Now this is 2 v1 v2 divided by v1 plus. So 2 by v is equals to 1 by v1 plus 1 by v. This is the equation, okay? Or I should say this is the average velocity of that specific person when he has traveled with two different velocities, but in this different intervals with the same distance. All right. Let me just draw a diagram over here for this question again. So what they have done is, from point 0, this person has started. He has went till a distance x, okay, with a velocity v1. Now he has traveled with the same distance x, but with velocity v2. You just need to calculate v average. Everybody knows the formula v average. This is the formula, correct? Sum of the both distance divided by sum of time taken at both the distance. So time taken will be nothing but x by v1, correct? Okay. I hope this makes sense. All right. Next, a particle of unit mass undergoes one-dimensional motion. Okay, it's again straight line motion. No issue. Such that its velocity varies. Sorry. Such that its velocity varies according to v of x is equals to v of x to the power minus 2n. Okay, so they have given the equation of velocity. All right, this is similar to the first question where we deal with the equation of acceleration, correct? So now they have said that where v and n are constant and x is the position of particle. So what they have said is that v of x, okay, let me write it here. They have told us that v of x is equals to vx to the power minus 2n. E and n are basically sorry, constants. Okay, these are constants. So the variable over here is nothing but x. All right, the position of particle. Now they have represented the velocity of that particular particle in terms of the distance of this particle, this equation. That is what they have told over here, right? That is what they have told over here. Until now, this is clear. Now they have asked the acceleration of the particle. Okay, it's very easy. So understand, they have given you velocity. Okay, they have given you velocity. What you have to do to calculate acceleration? What? So there should be some relation between acceleration and velocity, correct? Right? This makes sense. There should be some relation between acceleration and velocity. Now we know that there's only one relation between acceleration and velocity. That acceleration is nothing of rate of change of velocity with respect to time. That's all. Okay, correct. So this is what they have given us over here, right? So A is equals to dv by dt, okay, which is dv by dx into dx by dt. See, they have told us it is dv by dt. Now, if you have studied differential equations, then we can just derive this differential equation in terms of dv by dx into dx by dt, correct? Velocity will be dependent on distance and distance will be dependent on time, correct? Overall, the velocity is dependent on time, correct? What we can do is, we can just break this differential equation in two parts. That is dv by dx. What is dv by dx? It says that the velocity is dependent on distance. It's correct. Now this distance, what is it dependent on? It is dependent on time. So we have broken this. This is what uh, acceleration is about. So this is v dv by a is equals to v dv by dx. Okay, because dx by dt, the rate of change of distance with respect to time is velocity. Okay, please don't get confused. Understand that rate of change of distance with respect to time is velocity, and rate of change of velocity with respect to time is acceleration. All right. So yeah, just a minute. Yeah. So what's the reason that we have just derived another equation of acceleration? Why wouldn't we be happy with the equation of a is equals to dv by dt? Should be a question in your mind, correct? Why we didn't derive an equation of acceleration with respect to time? Because we don't have anything of time as in this question. You just notice over here, they have just told about the equation, and the equation is in terms of position, not in terms of time. If it would have been in time, then we just need to directly compute the differentiation of this particular equation. But it is not that, but it's not pretty straight. Okay, what we have to do is, we have to compute acceleration in terms of position. For that, we had just computed extra differential equation over here. All right, cool, cool. So what we are going to do is, we are basically going to v dot dv by dx. So dv by dx is nothing but minus 2n dx. Okay, what was velocity? V of x. Let me write it. V of x is dx minus 2n. So you just calculate dv by dx. This is minus 2n x minus 2n minus 1. Pretty straightforward, right? What is the differentiation? What is d by dx of x to the power n? What is d by dx of x to the power n? N into x to the power n minus 1, correct? This is what I have written over here, right? And b is your constant. dv by dx, I have got it. dv by dx is nothing but minus 2n dx to the power minus 2n minus 1. All right, correct? Fine. Now the acceleration of particle will be represented by v dv by dx. Again, just need to replace this v by dx to the power minus 2n. All right, this is what we have got over here, and this is what we have got over here, dv by dx. So eventually, your answer is minus 2n v square x to the power minus 4 and minus. All right. Okay. Now, one thing which has to be mentioned over here is that, for understand one thing, that for one-dimensional motion, okay, I'm specifically talking about one-dimensional motion only. I'm not talking about two-dimensional. One-dimensional motion means motion in a straight line. Okay. So if you're in a motion in a straight line, then the angle between the velocity and acceleration is 0 degree or 180 degree. Fine. and it does not change with time. You have to note this thing, right? So important note is that for one dimensional motion, the angle between velocity and acceleration is either 0 degree or else it will be 180 degree. Okay, and it won't change with time. It won't change with time. Okay, let's move to the next question. The displacement x. All right, the displacement x in meter of a particle of mass m in kg moving in one dimension under the action of a force is related to time in seconds. Okay, so what they have said is that, okay, so basically they have given us an equation of time with respect to displacement. Okay, the displacement of the particle when its velocity is 0. All right, interesting. It's a simple question, nothing. So what they have said is that t is equals to root x of root x plus p, right? So what you do is you just put everything in terms of root x. So root x is equals to t minus 3. Okay, x is equals to t minus 3 whole square. I've got an I've got position in terms of time. Now what I have to do is they have asked us what if the velocity is 0, right? So velocity is nothing but dx by dt, which is nothing but 2 into t minus 3. All right. This have been computed. You just put t is equals to 3. You just put t is equals to 3. So if you put t is from this t is equals to 3, right? And from this equation, x is equals to t minus whole square, which is 0. They have said that what if the velocity is 0, right? So you just compute 2 into t minus 3 is equals to 0. This is normal linear equation, right? So what is the root of this linear equation? 3. So at time is equals to 3, I can say that the velocity will be 0. Now, to calculate the position of that specific particle, just put t is equals to 3 in the original equation. Simple. It's as simple as that. So we'll get x equals to 0. All right. What they have said is that at this specific time, okay, when the particle velocity is 0, what will be the displacement that will be traveled? That will be 0. Okay. So now a very common sense to be applied in this question is that we have a specific time, correct? We have a specific time and displacement of a particle given, right? The displacement of the particle when its velocity is 0. You just don't need to calculate these all stuff. All right. You just don't need to calculate these all stuff. I'll tell you why. Because they have mentioned that displacement of the particle is to be calculated when the velocity is 0. If the velocity is 0, particle is not going to travel at all, which directly can tell that the particle is initially at rest. Okay, so they are asking what is the displacement of that specific particle when it is at rest. It is already 0. So if you have a bit of intuitive skills, you can directly take option C and move to the next question. Okay, and if you have calculated like this, there's no problem. You are still getting your answer. But the second trick over here, which I have told, okay, that will save a lot of your time. I think approx 1 or 2 minutes. Right? Okay. So more frequently we usually get these kind of questions in your NEET and JEE Mains. Okay. As you can see, this is a PYQ question of 2013. So since it's a PYQ question, you can expect it to come in any of the exams. All right. Okay. Now the next question, question number 5, PYQ question 2012. A particle has initial velocity 2I cap plus 3J cap. Okay. So now we have seen questions where we have dealt with displacement, time equation, acceleration, as well as velocity. More or less, everything is covered in terms of equation. Now, there's new possibility, that is vector representation. So that is what given to you over 2I cap plus 3J cap. Okay. And acceleration is 0.3 I cap plus 0.2 J cap. the magnitude of velocity after 10 seconds. Simple. You just need to compute this. See, so v vector is nothing but u vector plus a vector into. All right, it's a normal what to say, equation of motion. All right, all right. So you have to find magnitude of v vector, which is under root of a square plus b square of whatever vector. Let's say the vector at the end you get ai cap plus bj cap, right? The magnitude of this v vector will be a square plus b square, right? Five I cap plus 5 j cap they have got over here. What you have to do is square plus 5 square, that is 5 root 2. Okay, again you have to take the square root of that specific function, right? So it's 5 root. Okay, now understand one thing. Why have we considered this equation? Because if you have studied the basic equation, like many of the students will have a doubt that why have we taken a vector representation of this specific, because normally the equation is in terms of normal coordinate system, right? We not coordinate system. What will you say? V is equals to u plus at, correct? We normally take it. Why we add vectors? Just because we have vector format of velocity and acceleration, that's why we are just adding an extra arrow? No, this is not the reason. More or less, this is a very lame reason. The exact reason is that, see what they have said, 2 I cap plus 3 j cap is velocity, right? Velocity is 2 I cap plus 3 j cap, correct? And acceleration is nothing but 0.3 I cap plus 0.2 j cap. See, the reason is that whatever the coordinate system is present, okay, in this 3D world, those all can be represented in a vector format. Understand one thing, that at the end, okay, at the end, everything is a representation of a vector system as well as a coordinate system. So let's say that I'm at a specific coordinate or I'm at a specific position from my house. Let's say I'm standing 2 kilometers far from my house, okay, 2 kilometers far, and currently I am on the ground. So if I'm on the ground, then y-axis will be 0. So I'm basically standing at coordinate 2 comma 0 from my house. That's correct, right? Now this same thing can be represented in a vector form. This 2 I cap. All right. So understand one thing, that your equation of motion is just not at the plane surface or at the normal linear system. Okay, it's at a vector system also. Understand? You'll get to know the importance of this vector representation in your mathematics when you study vector equations and 3D geometry. All right. So to sum it up, what we have done is that they have given us velocity, they have given us acceleration. We just need to find initial velocity. Okay. Sorry, they've given us velocity and acceleration. Okay. Yeah. So we just need to find the magnitude of that specific velocity. So we will just use the simple equation of motion, which was final velocity is equals to initial velocity plus acceleration into time. Correct. And this will be represented in a vector form. Just jot down the values, and then you just need to find the magnitude of that specific vector. Okay. It will be under root of a square plus b. Fine. Okay. Now let's move to the next question. This is question number 6. The motion of a particle along a straight line is described by the equation. Okay, it's again motion of a particle. It's described, and looking at the quantity, this says that t is equals to t and x is in meter. That means x is displacement basically. What is the retardation of the particle when this velocity becomes 0? Okay. Now question arises: what is retardation? See, so everybody knows about acceleration over here, right? So acceleration happens when this is basically in the direction of the velocity as well as the particle's motion. That is acceleration. Okay. So when the rate of change of velocity effect time is in the direction of the velocity, that is called as acceleration. The same acceleration, if it is in opposite direction, that is called as retardation. So basically, if I'm retarding, okay, if I'm retarding, that means I'm going to basically stop. All right. So if I'm moving with a specific speed or velocity, so I will be having an acceleration. But when the same speed is reducing, this is going to become a retardation. And the denotation of retardation is nothing but minus a vector or minus a, whatever you use. Okay. So in your equation of motions, instead of a, you just need to put minus a. All right. There's no more change. There's no more change. Fine. So what we have over here is x is equals to 8 plus 12t minus e cube. Okay. Final velocity will be 0. So final velocity will be 0. That is, what do you mean by final velocity will be 0? We have to calculate dx by dt first. So x is given to me as 8 plus 12t plus minus t cube, right? Minus t cube. Fine. What we have to do is, they have told final velocity. Okay. So it's dx by dt. Calculate the differentiation. The differentiation over here is t plus 12 minus, let this 3 come down, 3t square. Okay. Now they have said that dx by dt is 0. So v is equals to 0 plus 12 minus 3t square, 0. 3t square is equals to 12. T square is equals to 4. So t is equals to 2 seconds. All right. T is equals to 2 seconds. Now the time is 2 seconds. So acceleration is equals to the rate of change of velocity with respect to time. That is 0 minus 6t. All right. So a is equals to minus 12 meter per second. See, whatever acceleration you have got, you just put minus in front of it. That is also one simple thing. Okay. Do everything what you have done. And in the end, when you get the value of acceleration, you just put minus in front of it. But note one thing, that if a is equals to minus 12 meter per second square, this means that retardation is plus 12 only. Acceleration is minus 12, but the retardation is plus 12. Okay, so don't get confused over here. So the answer for your question is option D, which is 12 meter per second square. Okay, fine. Okay, okay. Let's move to the next question. This had come in previous year. A body is moving with velocity 30 meter per second towards east. All right. Body is moving with 30 meter per second. It has a velocity. It's moving towards east. After 10 seconds, its velocity becomes 30 meter per second towards north. Then what's the average acceleration? Now, this is something in a vector representation. So I'm assuming that this is in a vector format. Correct? So what is acceleration? Acceleration is nothing but rate of change of velocity by total time. What is rate of change of velocity? First it was 30, then it was 40. Correct? That's correct. First it was 30. Now this is 40. Correct? Divided by total time. So the total time is nothing but 10 seconds. Okay? So acceleration is nothing but, so the final acceleration will be 40 j cap minus 30 I cap divided by 10. All right. So your acceleration is nothing but under root of magnitude, that is 4 square plus minus 3 square. Acceleration is nothing but 5 meter per second square. All right. A particle has initial velocity 3 I cap plus 4 j cap and has an acceleration of 0.4 I. Okay, this is the same question which we have done. And the only change in this question is that what is the speed after 10 seconds? This is the entire thing. Okay. So they have given us initial velocity. They have given us acceleration. So ux is nothing but 3 units. Uy is nothing but 4 units. Correct? Acceleration and unit is given. So along x-axis, ex is equals to ux plus ax into time, 10 seconds. And along y direction, vy will be equals to uy plus ay into 10. This is the components in x direction and y direction. So the final velocity f vector will be nothing but 3 I cap plus 4 j cap, okay, plus 0.4 I cap plus 0.3 j cap into time, which is 10 seconds, which is 7 I cap plus 7 j. Because the main velocity over here will be under root of vx square plus vy square, right? The main velocity is 7 root 2 meters. 7 root 2 units, sorry, not meters. Okay, whatever the units, because they have not specified any units, so it will be 7 root 2 units. All right. So the speed, so the particle speeds up. That is, the speed of the particle increases when the angle between A and okay, when the angle between A and B lies between 0 and 90. Okay. So if the angle between velocity and acceleration is 0 to 90, then the particle speeds up. And if the what to say, acceleration and velocity angle is around 90 to 180, then the speed of the particle will be going to reduce. Okay, let's take in a coordinate system. Okay, now whatever is the coordinate, let's say that 0 degree, 180. Yeah, represent this coordinate system in your 3D world. So they are saying that if a specific particle is moving in this direction and the acceleration is in this direction, just understand one thing. Or at the end, this is in the first coordinate, right? Correct? And if they're saying that it's moving here, but moving in this direction, then this is the opposite. So if you have a bit of knowledge about coordinate geometry, then you'll say that the speed will increase in the first coordinate and the speed will reduce in second quadrant. So you don't need to do this much computation over here if you have a bit of knowledge about coordinate geometry. Okay, just represent everything in a coordinate system. Just mark out all the quadrants, and you just figure out which particular speed is moving in which what to say, direction or coordinate, right? All right. A particle moves a distance of x in time t according to the sequence. Okay, we have done a lot of questions. The acceleration of a particle is proportional to. Okay, now they have asked us acceleration. Okay, so what they have given is that x is nothing but 1 divided by t plus 5. So dx by dt. First, need to calculate velocity, right? This will be nothing but d by t of t plus 5. Sorry, t plus 5. All right. Which is minus 1 by t plus 5 whole square. Correct? Okay. So what they have given is that x is there. First, you compute the velocity. Velocity is nothing but minus 1 divided by plus 5 square. Now they have told us to compute acceleration. So acceleration is nothing but d2x by dt square, which is nothing but dv by dt, which is 2 divided by t plus 5 whole cube, which is 2x. Fine. So this says that v to the power 3 by 2 equals to minus of t plus 5 to the power minus 3, which says that acceleration is directly proportional to the 3 by 2 power of velocity. Okay. So A is proportional to v to the power 3 by 2. That is velocity to the power 3 by 2, and your option A is correct. Okay. Fine. I hope everyone are on the same page. Fine, fine. Let's move next. Okay. So this was a solution. A particle starts its motion from rest under the action of a constant force if the distance covered in the first 10 seconds and S1, okay, first 10 seconds and S1. Okay, so what they have told is that in the first 10 seconds, it travels S1, and first 20 seconds it is traveling S2. So what is the, okay, fine. So they are asking basically the relation between S1 and S2 over here, correct? See, so the initial velocity is 0 because it was at rest. Time t1, time t2 is s. So s is equals to ut plus half at square, correct? Calculate s1, calculate s2. All right, you just divide s1 by s2. So initial velocity is 0. It's not new, okay? It's t is equals to 10 seconds. T2 is equals to, that was T1, okay, sorry. T2 is equals to 20 seconds. We know our equation of motion where we have initial velocity, time, as well as acceleration, which is S is equal to ut plus half at square, correct? So S1 is equals to 1 by 2a into T1 square. S2 is equals to 1 by 2a into square, okay? S1 by S2 is equals to T1 by T2 whole square, correct? Because at the end the constants are going to get slashed. That is 10 by 20 whole square, which is 1 by 4, which says that S2 will be equals to 4 times of S. This is what written over here. Okay, just referring it. Fine. S2 is equals to 4S1. S2 is equals to 4S1. Where is S2 is equals to 4S1? Option B. So we didn't have to do anything. We just had to follow this specific uh, second equation of motion. Yeah, we had to follow second equation of motion. Okay, so I hope everybody are clear with this question. Let's move to the next question. The distance traveled by a particle starting from a rest. Okay, starting from rest. So if starting from rest, then the initial velocity is 0. Fine. U is equals to 0. And moving with an acceleration 4 by 3 meter per second square in the third second. Okay, so the distance traveled in the third second. So Sn, you have to calculate the fourth equation of motion. Excuse me. Sn is equals to u plus a by 2 into 2n minus 1. Okay, this specific equation tells that what will be the particle of that specific second, the how much has it traveled in the fifth second. All right, okay, so this is the graph. Okay, this is the next bit. The next bit. Just a second. Okay, a particle shows distance and time curve as given in this figure. The maximum instantaneous velocity of the particle at this point. Where is the maximum instantaneous velocity? So you have to calculate the slope. Okay. What is instantaneous velocity? Instantaneous velocity. See, instantaneous velocity specifically tells that what is the velocity of that particular particle at a particular instant. All right, at a particular instant. Just a second, I think over here. Yeah, somewhere C will be, I think, over here. C is over here, guys. There's a mistake. Fine. At that specific instant. Now, if you have studied the differentiation, so what is instantaneous? Something which is instantaneous on a specific curve. So on a specific curve, if you need to calculate any quantity at that specific instant, what you will be doing is you will be just calculating the slope of that specific curve. Everybody knows how to calculate slope. Slope. So you just need to make a line over here like this. Okay. At point A also, make it over here. This is at point, make it over here. Okay. So at point B, the slope is 0. So this will be 0 for sure. Okay. Now, a simple trick, what I would say you all over here is that whenever you're calculating the slope, okay, just see the right side of the slope. See, this is the right side, correct? The right side, not the left side, not the left side. Just see always the right side. So the right side is basically going upwards. That means it's positive, correct? Now this is going more upwards, correct? More instantly it is going upwards, right? So point C has a maximum slope, and if you calculate point B, it has almost gone stagnant. So the slope at point B and point D is 0. B comma D is 0. Okay. And at a point A, it is increasing. At point C, it is increasing. But if you see the slope length, the C over there, here, okay, this is increasing, but this is gradually increasing, right? So C is my correct option. That is option B. Okay, just don't get confused with the option. Fine. So you need to calculate the slope of that specific point at a curve. Okay. Okay. What if they would have told you to calculate velocity? So if they have told you to calculate velocity, you just need to convert this xt curve into pt curve. And if they need to tell you about acceleration, then it is AT curve. Okay, so the curve will be changed, but the calculation of slope will be the same. You may get some different curves or something. All right. So this is what they have told us. So V instantaneous, okay, just note the formula, is nothing but limit delta t extends to 0, es by del s by del t, which is ds by dt. All right. So listen, when limit is tending to 0, when there is a very small change, okay, when there is a small change in time and small change in distance, we need to calculate the velocity at that specific point. That is instantaneous velocity. Okay, instantaneous velocity of an object is given by instant of first derivative of displacement with respect to time. The slope of this displacement time graph at any instant of time gives the measure of instantaneous velocity of an object at that specific. Okay, I hope this should be clear. Fine. Okay, let's move to the next question. Okay, Preeti reached the metro station and found that the escalator was not working. She walked up the stationary escalator, in time t1. On other days, if she remains stationary on the moving escalator, then escalator takes her in time t2. Then what is the time taken? Simple. Just need to calculate velocity v is equals to v1 plus v2. That is distance by time is equals to distance by time 1 plus distance by time 2. Correct? So velocity v1, velocity v2, you compute the velocity respect to distance and time in their own individual places and equated it in the final time equation. Okay, what I mean to say is that velocity is nothing but distance by time. So initially in the first scenario, velocity was v1. So the equation will be v1 by d1. Sorry, equation will be d by, divided by t1. Okay, if it is velocity v2, then it is d by t2. Correct? Correct? Right? So what they have told you is that you have to calculate d by t at the end. Okay, that is d by t1 plus d by t2. From this simple equation, 1 by t is equals to 1 by t1 plus 1 by t2. Right? Correct? So at the end, you need to calculate time. Just compute it with this equation. So you get time as t1 t2 divided by t1 plus t. So this is the time taken by Preeti to walk upon a moving escalator. All right? Fine. Next question. If a particle moves in a straight line with a constant acceleration, okay, it's a constant acceleration, it changes its velocity from 10 meter per second to 20 meter per second while passing through a distance of 135 meter in t seconds. Then what's the value of t? Okay. Now see what they have given is, they've given us the third equation of motion. All right. This one. They've given us the third equation of motion. Initial velocity is 10 meter per second. Okay. Final velocity is 20 meter per second. And S is equals to 135 meter, correct? So we have S, we have U, we have V. Now just think of an equation of motion which consists of V, S, and U. That is V square is equals to U square plus 2AS. Okay. You just need to put this. Acceleration is constant. You need to calculate acceleration first, correct? So A is equals to V square minus U square divided by 2S. Acceleration will be 10 by 9 meter per second square. Okay. Now you need to calculate time. Okay. So V is equals to U plus A. So use these two equations of motion. Once you have computed the acceleration, what they have told, they have told to calculate final velocity, right? They have told to calculate final velocity. Final velocity, you have initial velocity, you have specific time also, you don't have acceleration. So to get acceleration, they had just given you this specific distance of 135 meters so that you can calculate it from the third equation. Okay? Excuse me. The position x of a particle with respect to time t along x-axis given by x is equals to 90 square. It's again the same question. So speed is nothing but dx by dt, correct? Speed is dx by dt, and you just need to calculate at time is equals to t maximum. Okay. One learning over here. Let's say that in anything, okay, if it's in maths and if it is in let's say physics or maths or physics only. Let's say they have mentioned anything about maximum, and you very well know that there are differentiation equations involved in that. Okay, what you have to do in this situation? Just a second. If they have mentioned a word called maximum, or let's say minimum, or anything, okay, what you have to do in that situation? In that situation, you just need to do differentiation is equals to 0. Let's say that speed is equals to speed is maximum. That means dx by dt is equals to. Okay. See, a very simple. I hope you all will be knowing about this curve, right? So, so dx by dt is so maximum velocity of a particle will be over here, right? That means dx by dt is this specific position. I just needed to give you an example of parabola. You can take any other. Okay. For maximum speed, its acceleration should be 0, right? dv by dt is 0. Fine. Just one learning over here. Rest of all these things are going to be same. Fine. A particle moves along a straight line OX. Let's see. So they have given us an equation x. Calculate the velocity, which is dx by dt. For v is equals to 0, you have the time. Similarly, need to calculate for velocity after 2 seconds. Okay. That is x in 2 seconds. Fine. Now, the displacement x of a particle varies with time. Okay. Now, this is again the velocity of a particle will be. Simple equation, guys. It's no answer D. Okay. See, they have given us x is equals to e to the power minus alpha. Sorry. Yeah. X is equals to a e to the power minus alpha t plus b e to the power beta t. A, b, beta, alpha. These are positive. Varies with time. Correct? It will be increasing, obviously, because the angle is always same, right? The velocity is in the direction of that specific particle. Fine. So no solution required. Direct option. Fine. The displacement of a particle is represented by the following equation. Okay. So this is the displacement. Okay. Displacement. Okay. Displacement. Fine. So okay. Let's see what do we have in this question. So S is equals to 3 T U plus 7t square plus 5t plus 8. What they have told, acceleration. Fine. So to compute acceleration, you have to first calculate ds by dt. This is velocity, correct? This is, so the 3 will come down, that is 3 is 9t square plus 14t plus 5. Okay. Now we calculate acceleration. That is acceleration. That is dv by dt. Correct. This is 18t square plus 14. Correct. Now a is equals to dv by dt. Correct. So acceleration is nothing but 18t square plus 14. This is what we have got. What they have told us at time t equals to 1. So at time t equals to 1, it is 18 plus 14. Okay, you just need to put a is equals to 18 into 1 square plus 14. That is 18 plus 14. What is 18 plus 14? 30. So acceleration of a specific particle is 32. I hope now you're familiar with a lot of questions of 1D motion, because you don't have much questions in this. Seriously, you don't have much questions in this. You just have questions revolving around 4 equations of motion, their differential format, their vector format. Okay, a bit of curves which we discussed, like instantaneous velocity and everything. That's all. Converting the curves in uh, like one curve with respect to other curve, right? Fine. A car moving with a speed. Okay. Like a car moving with a speed of 40 km per hour can be stopped by applying brakes at least after 2 meters. The same car is moving with 80. What will be the thing? Okay. Calculate it. So you have to calculate first the acceleration. Okay. Now the retarding force will be directly proportional to the velocity, right? So you'll get it. Okay. Next question. The displacement of a particle varies with time t as s is equals to at square minus bt cube. The acceleration of a particle will be 0 at time what? Simple. Compute ds by dt. You have to compute dv by dt. You get 2a minus 6bt, correct? So 2a minus 6bt is equals to 0. They are saying acceleration will be 0 at what time? Time will be a by 3b. Okay? A by 3b. Correct? Fine. Next question. A car accelerates from rest at a constant rate alpha for some time, after which it deaccelerates at a constant rate beta and comes to rest. If the total time elapsed is t, then the maximum velocity acquired by this car. Similar question, right? So you have to calculate the area basically over here, right? So this area, you have to nothing but calculate this area and then calculate this area. You'll be getting your answer. Displacement, again, instantaneous velocity question, very easy. So at slope e, the slope, right? So at slope e, the velocity of this specific particle is more, right? So instantaneous velocity of e is more over here, because the slope is going much steeper downside over at specific position e. At c it is going up, at d it is stagnant, at f it is going up, but at e it is coming majorly down, correct? So what you have to note is that uh, the instantaneous velocity at point E is more, correct? Okay, I hope everyone already are at the same page, because at E, the slope of the curve is negative. The line bending towards the time axis represent decreasing velocity of negative velocity of that particular particle. This means that the particle possesses retardation, correct? Negative at a point. So negative at a point means it's E, okay? If they have asked maximum, then this would be have at point C or at point F. You have to just note down about that thing. Okay, it can be at point C or at point F. A particle moves along a straight line such that its displacement at any time. Again, what is the velocity when acceleration is 0? So you need to calculate a is equals to dv by dt. Simple. So what you have to do here is that they have given you displacement, right? from displacement, you calculate the equation of acceleration. You put everything 0 in that. Okay, you'll get some specific time, right? Time. Let's say time was 2 seconds. Now put this value of time in 2 seconds in. That is where you will be getting the velocity. Okay. A particle covers half of its total distance with time v1. Okay, with speed v1, and the rest half with its speed v2. It's average speed. Again, it's an average speed question, guys. So it's a direct formula. We basically memorize it. So v average is nothing but QS divided by S by v1 plus S by v2. There's nothing but 2 v1 v2 divided by v1. Okay, nothing nothing new. It's the same formula. Just need to apply the formula in that specific question. Okay. Okay. So last question of the day. A body starts from rest. Okay. A body starts from rest. What is the ratio of distance traveled by the body during the 4th second and the 3rd second? Fourth equation of motion will be applied. Okay. So S4 is equals to 0 plus A by 2 into this thing. Okay. 4th second and 3rd second. Okay. Correct. Equation of motion is Sn is equals to U plus A by 2 into 2n minus 1. Let's say if it is 4th second, so it will be S4. 3rd second, it will be S3. So n is equals to 4 comma 3 we have. We have acceleration also. We have initial velocity, which is just need to divide the ratio of this. So the ratio of S4 by S3 is nothing but 7 by 5. 7 by 5. Where's 7 by 5? Option A. Simple. Okay. So this what it is. This was it. Okay. So what I want you all to do is go through these questions, revise them. Okay. We still have around 20 to 25 questions more. Okay. We're discussing that in the next class. Until then, just practice this kind of variety of questions for equation of motions, representation in the differentiation, then in the vector equations, then memorizing the curves of specific functions like S versus T, B versus T, A versus T. Fine. How to convert one graph to another graph format. Okay. Then the next variety of question is that, yeah, that's it. Okay. So if you want any practice reference or something, you can go through the previous year questions. That's the best resource. Okay. Until then, keep practicing and take care. We shall meet in the next class. Okay. So thank you very much for attending this session.